you are welcome back to my channel. And in today's physics class, we shall be talking about a key topic in physics, which is thermometry. So without wasting your time, guys, we'll be getting started now. Now take a look at this. The first thing we're talking about for today is what I call temperature scales. We shall be looking at the different scales that are used to measure temperature. And there are three major scales, though there are others. We have the Celsius scale, we have the Fahrenheit scale, and lastly we have the Kelvin scale. I must bring to your notice also that the Celsius scale is also called the Centigrade scale, while the Kelvin scale is also called the Thermodynamic scale. Now take note, they have their own different units, their own different respective units. For the Celsius or Centigrade scale, the unit is degree Celsius. For the Fahrenheit scale, the unit is degree Fahrenheit. While for the Kelvin or the thermodynamic scale, the unit is just Kelvin. It does not go with degree. So observe those slight differences. Okay? Now, this is the usual representation of a scale. This is how a scale is usually presented as. Okay? This is how it is presented as. Now, there will be a value at this place, another value at this place. Now, the value at this place is called the upper fixed point, while the value at this point is called the lower fixed point, corresponding to the fact that this one is up while this one is down, just like trying to make things basic. Now, there is an interval between the upper fixed point and the lower fixed point. Okay? That interval between them is called the fundamental interval, symbolized by Fi. So this is the usual presentation. A value for the upper fixed point, a value for the lower fixed point. Now we know the different type of scales. I'll be giving you guys and explaining this table that we have here. Okay? This is for the three type of scale, the three major type of scale. The Centigrade scale, the Fahrenheit scale, and the Kelvin scale. Now what should you know about these three type of scales for exam purposes? You should know their upper fixed point, you should know their lower fixed point, and also you should know their fundamental interval. Is that clear? So let's start with the degree centigrade scale, okay, or the Celsius scale. The upper fixed point of a Celsius scale is 100 degrees Celsius. Now take note, how do they get upper fixed point? And how do they get lower fixed point? And how do they also get the fundamental interval? Starting with the upper fixed point. The upper fixed point corresponds to what is called the steam point. And what does steam point stand for? It is the temperature at which water boils. Okay? Just trying to be basic. Okay? You can get more standard definition from textbook. So the temperature at which water boils, which we know to be the boiling point, is what is given as the upper fixed point. So if I was to carry a centigrade thermometer and insert into a boiling water, okay, the temperature it will record is what? 100 degrees Celsius. Okay, and that is the temperature of steam. Okay, take note of that. But if I was to do that same measurement with a Fahrenheit scale, let's say water is boiling and I put the thermometer so that the steam can be condensing on it. The temperature that it will record with a Fahrenheit scale is 212 degrees Fahrenheit. While with a Kelvin scale, the temperature at which the thermometer will read is going to be 373 Kelvin. Okay? So the steam point corresponds to the temperature of what? Boiling water, which is specifically, we are talking about the steam that is being given off. The temperature of the steam is what is called the steam point. Now for the lower fixed point, we are talking about the temperature of ice. Okay? And that corresponds to the temperature of freezing water. I hope that is clear. So when you insert a centigrade thermometer or a Celsius thermometer into water that is freezing, the temperature it will record is 0 degrees Celsius, and that is the we say the upper fixed point minus the lower fixed point. Upper fixed point minus the lower fixed point. Last week, upper fixed point minus the lower fixed point. So let's see what it will be. 100 minus 0 will give us 100. So for a Celsius thermometer, the fundamental interval is what? 100. For Fahrenheit scale now, 212 minus 32 will give us what? 180. So the fundamental interval of a Fahrenheit scale is 180. Now lastly, for a Kelvin scale or a Kelvin thermometer, let's see what we have. 373 minus 273 will give us exactly 100. So these are the values you should be aware of before you start anything relating to thermometry. Okay? So guys, now we know this, we'll be moving forward to what we call temperature scale conversion. This is the basic level of calculation you will find under the topic thermometry. Now what does it have to do? Sometimes you'll be given a temperature reading with one scale, and you'll be asked to convert that temperature reading to that in another scale. Okay? Let's say they'll tell you convert 360 Kelvin to Celsius. So that's an example of what I'm talking about. Convert 50 Fahrenheit to Kelvin. That is an example of what I'm talking about. And it's important to know that there's a simple relationship joining that of Kelvin to that of Celsius to that of Fahrenheit. And this is the simple relationship you should know for these very aspects. Once you know this, you are good to go. That Celsius is equals to Kelvin minus 273, and that is equivalent also to 5 in brackets Fahrenheit minus 32, everything divided by 9. So if I was asked to convert from Kelvin to Fahrenheit, I'll be joining this with this. So I'll just pick this and equate it with this. If the value was given for the Fahrenheit, I'll put it here. Then using my normal mathematical manipulation, I'll get the value for K. If I were asked to convert from Celsius to Kelvin, this is the one that has to do with Celsius, this is the one that has to do with Kelvin. So I'll just combine this and this. I'll say C is equals to K minus 273. So if the value of this was given, I'll put it here and make K subject. If the value of K was given, I'll put it here and I'll get my answer for degree Celsius. So it's that easy. Just know the relationship, combining or joining the three different types of scales. So take a look at all these because these are the preliminaries, what you should have at the back of your mind. So guys, now we're going to something different, which is called thermometric conversion. Converting different thermometric properties into their reading with all these major type of scales. Okay, so you'll be given a non-standard thermometer and you'll be asked to find the reading with a standard thermometer. Like saying, if this is a non-standard thermometer, this thermometer was gotten using no other thermometric property. If it reads so and so, what is the equivalent with any of these type of scales? That is what you'll be doing here. And this is the main calculation under thermometry. This is the main one. This is one you should I say, focus more on. So if they will ever set a question on thermometry in, let's say, UTME and post-UTME, they would like to give you guys something like this, okay? So let's get started. Before we get into thermometric conversion, there's something called thermometric properties you should be aware of. Now, I just give it a symbol here, X, because that's what I'll be using throughout. Okay? Now, if I was to give a definition to what thermometric property is, I will say thermometric properties are those properties that changes uniformly with changes in temperature. So as temperature is changing, these properties are also changing. Okay? You can call them thermometric quantities, just to be basic. Now let's say there is an increase in temperature. The length will change, it will also increase. If there is an increase in temperature, there will be a change also in resistance. And mind you, this change could be an increase or a decrease. So let's say whenever there is a change in temperature, either of these properties could be increasing, while some will be decreasing. So that's why they are called thermometric properties. So as temperature is changing, they will either increase or decrease uniformly. I hope that is clear. So example of this thermometric We have length, symbolized by small l. We have resistance, big R. You have volume, big V. You have pressure, big P. etc. They continue, the list continue. Okay? Now we know this. How do we now apply our knowledge of this? Now, sometimes you will be given a non-standard temperature, a non-standard thermometer, and the thermometric property used was resistance. They will say at ice point, the non-standard thermometer read a value of, let's say, 32 ohms, because that's the unit for resistance. They will now say at steam point, it read a value of, let's say, 100 ohms. Okay? They will now be like, if the resistance at an unknown temperature is, let's say, 50 ohms, find that temperature in degrees Celsius. So you are using a non-standard thermometer that varies in terms of resistance, and you are going to be finding the value within what degrees Celsius, something like that. When you start taking question on this, you understand better. So let's see what we have here. If you were asked to find the value of that thermometric property with a Celsius scale, this is how it works. First of all, draw the scale. We know that for a Celsius scale, the upper fixed point is 100, the lower fixed point is 0. Now they will give you a value for these two. X1 stands for the value of the thermometric property at steam point. Okay? X0 stands for the value of the thermometric property at ice point. Okay? Now, they will give you this one. This one will be the thermometric property at the unknown temperature, which you have to decide yourself, which are going to be finding. They will say if at an unknown temperature, the thermometric property is now, let's say, 30 cm, let's say 50 ohm, let's say 300 cm cube, let's say 100 millimeter of mercury. What is the corresponding temperature? That means it's T that is unknown. So this and this will be provided. This you already know them. So you'll be made to find the unknown temperature. So for a Celsius scale, the formula to use is this. Just simply make T subject. T over 100 is equals to x minus x0 over x1 minus x0. Like I said, x is the value of the thermometric property at the unknown temperature T. X0 is the value of the thermometric property at ice point. X1 is the value of the thermometric property at steam point. Okay? They will give you those values, then you can make your T subject and get your answer. But if you were asked to find your answer using a Fahrenheit scale, that means give us your answer in degree Fahrenheit. This is what you should be using. Okay? We know that for a Fahrenheit scale, the upper fixed point is 212, lower fixed point is 32. Then this will be given, like I said, these are the steam points will be given to you. These are the high points will also be given to you. Then this will also be given. Then you'll be made to find temperature. So for this case, this is what you use. T over 180. How do we get the 180? 212 minus 32 give us 180. Is equal to something similar here. How do we get the 100? 100 minus 0. Now, how do we get all this formula? It's based on a method in mathematics called the method of what? Extrapolation or interpolation. Okay, that's what we use here. It's simply saying whatever you are doing to this side, do that same thing to this side. So if I say T minus 0, what will I have? T. Is it not? So because I use second and last, I should also use second and last. So I'll say x minus x0. That's how we got it up. Over 100 minus 0. I said the third and the first. That gives me 100. Then I'll also say for the other side, I'll say x1 minus x0. That is how we got the formula. So let's see the same thing here. Whatever I do on this side, I should do the same thing on this side. On this side and this side, I should do the same thing. So if I'm saying T minus 32, okay? Yeah. T minus 32. Thank God I saw it. Now if I'm saying T minus 32, I should also say x minus x0. And that's what we have here. So if I'm not saying 212 minus 32, which should give me 180, I should also say x1 minus x0. And that is how we get the formula. So when you finally make your T subject, the value for the thermometric property in degree Fahrenheit. Now for a Kelvin scale, okay, let's just quickly correct all this. I've seen something. Now for a Kelvin scale, how do you work this out? If we say T minus 273, we should do the same thing on this side. X minus x0, which is what we have here. Everything over 373 minus 273 give us 100. So because we said this and this, we should also say x1 minus x0. And that is how we got the formula for this. So basically, this is what you need to know. In case you are given any of these values, you can definitely find for the unknown. So guys, I hope this revision and this summary on thermometry in general helps. Thanks for watching. See you guys in my next